Now let's start from where we left. In the previous one, we found out the value of yp. Now we will find out the value of yc. Yc is known as the complementary function. Now the complementary function of this equation, that is this one, y double prime of t plus a1 y prime of t plus a2y is equal to b, is defined as solution of its reduced homogeneous function equation. What happens is that over here we will say that y double prime of t plus a1 y prime of t plus a2y is equal to 0. In order to find out the value of yc, we will put the value of b equal to 0 for evaluating the value of yc. Okay. Now solution of the form y is equal to a e raised to power rt is applied in the case of second order differential equation. Y is equal to a e raised to power rt. Now from where has this come? I will just briefly go to the previous derivations of ours. When we studied the values of complementary function for simple first order linear differential equations, we got a e raised to power minus small a t. But when we are concerned with the higher order differential equations, we will get a e raised to power rt. It is applied in the case of second order differential equations. Now therefore yc is equal to a e raised to power rt. yc is equal to a e raised to power rt. Now what will we do? In our function we have two derivatives, that is the first order derivative and second order derivative. Now for this we have to find, it means that we have to find the two different derivatives. First the first order derivative and then the second order derivative. And from the assumption yc is equal to a e raised to power rt, it should not be equal to 0. Because if it is not equal to 0, then we can proceed ahead. Now y prime of t is equal to r a e raised to power rt. r a e raised to power rt. Why r a e raised to power rt? Because what happens is that, okay, let me solve it for you over here. A e raised to power rt is given to us. We want to derive this. We will take this on one side, let it be u and let it be v. That is u into derivative of v will become e raised to power rt. Okay, into, now we take the derivative of rt, that is again we will get u into derivative of t plus v into derivative of u. U is some coefficient, r is a coefficient, therefore its derivative will be equal to 0. Therefore it will become a e raised to power rt into r, that is r multiplied by 1 is equal to r. Therefore if we further open this, we get r a e raised to power rt. This is the first order derivative of this function, that is y prime of t is equal to r a e raised to power rt. Okay, now what will we do is that we will have to take the second order derivative as well, because in this function we have two derivatives, a1 prime y prime t, and the first one is the highest order derivative is y double prime of t. So therefore in order to take the higher order derivative, we will take the derivative of this function, that is r a e raised to power rt. Let's start it from here. Y double prime of t is equal to r square a e raised to power rt. That is, we applied the same methodology of derivative by taking the derivative of this function. That is, we will take it as this is also a coefficient and a is also a coefficient, only t is variable over here. Let me solve it for you over here. Now we have this function which we have to derive. We'll keep r and a on side. We will take the derivative of this function, that is e raised to power rt into u into derivative of v plus v into derivative of u, and therefore what happens is that by solving it further or simplifying it, we get, okay, by solving it further r a, we get e raised to power rt into r, and therefore rearranging this particular value, we get r multiplied by r a e raised to power rt, multiplying r with r will make it equal to r square, and therefore the higher order derivative is r square a e raised to power rt. So this is the higher order derivative. Now this is the highest order derivative over here, and this is the uh, and this is the first order derivative over here. Now what will we do over here after this is we'll substitute both the derivatives in the given general form. What is our general form? We know very well that it is y double prime of t plus a1 y prime t plus a2 y is equal to p. In y double prime of t, we will put the second order derivative that we evaluated. In y prime of t, we will put the first order derivative that we evaluated, and then we will write the equation again. That is, we get r square a e raised to power rt, okay, a e raised to power rt plus a1 r a e raised to power rt again, and then plus a2, and what we will get over here is simple a e raised to power rt, because the complementary function is a e raised to power rt. So therefore a2 a e raised to power rt, and then in the end what will we get is this whole is equal to 0, because this is the reduced form of equation. Complementary function is the reduced form of equation. A e raised to power rt is found in all these three terms. We will take it as common. Therefore, a e raised to power rt will be taken as common. What we will get in the bracket is r square plus a1r, okay, plus a2 is equal to 0. Okay, wait, is equal to 0. Okay, now what happens over here is that if we shift this a e raised to power rt on this side, we will get only this value, that is r square plus a1r plus a2 is equal to 0. Now what will be our next step? Our next step is we have to find out the values of R1 and R2. Therefore, the formula for R1 and R2 is equal to minus A1 plus minus, it is somewhat similar to quadratic formula, A1 square minus 4A2. Why it is similar to quadratic formula? Because the function over here has the highest derivative, has the highest second order derivative, minus 4a2 the whole divided by 2. Okay, now what will we get after this is that we will solve it. That is, we know that r1 r2 is equal to minus a1 plus minus square root of a1 square minus 4a2 divided by 2. Now we will add r1 and r2 first, like we did in the earliest explanation. R1 plus R2 is equal to minus A1 plus, okay, square root of A1 square minus 4A2 divided by 2, okay, and then over here we will have plus again minus a1 minus square root of a1 square minus 4 a2 the whole divided by 2. Now we can see that we can do one thing over here, that is this is plus a1 square minus 4a2, this is minus a1 square divided by 4a2. What is left over here is minus a1 upon 2, okay, and this is minus a1 upon 2. We have 2 minus a1s upon 2, that is we have minus a1 over 2 minus a1 over 2. Therefore, minus a1 over 2 minus a1 over 2 is equal to minus 2 a1 over 2, and simply we can say that the value of r1, the first root plus the value of r2, that is the second root, is equal to minus a. This is the value of minus a. Sorry, r1 plus r2 is equal to minus a1, not a. I'm sorry for that. I said minus a, which is wrong. It should be equal to minus a1. This is the sum of the roots. Now, if we want to find the product of the roots, what will we get is we will get r1 multiplied by r2 is equal to. Okay, now let's, before proceeding to this one, now what is the value of a1 in our question? Right. Now here, this we have evaluated this value through r1 plus r2. Now we will find out the value of a2 through r1 multiplied by r2. Therefore, our next step is to find out the value of r1 multiplied by r2. That is what we will get over here is minus a1 plus square root of a1 square minus 4a2 divided by 2 multiply by, again what we'll do over here is that we will multiply it with it, minus a1 minus a1 square minus 4a2 divided by 2. Now what we get over here is that we will get minus a1 the whole square, then minus, we'll get the square of this whole square root, that is a1 square minus 4a2 the whole square divided by 2 2s are 4. This square will be cancelled out with the square root. What will we get over here is that minus a1 the whole square minus a1 the whole square will become plus a1 square. So therefore we will get a1 square minus a1 square, and minus minus is plus, plus 4a2 divided by 4. These two will be cancelled out with each other, and in the end what will we get is we will get 4a2 divided by 4, okay, and 4 will be cancelled with 4. Therefore r1 multiplied by r2 is equal to a2. If the numerical values of a1 and a2 are given, we can find them through this methodology. So therefore we have completely solved this question, and we have evaluated these values of a1 and a2 through the roots. What were those roots? These roots we have studied in the complex functions as well. So we have y double prime of t plus a1 prime t plus a2y is equal to b. Yp is equal to b over a2, and yc is equal to, we'll start it from this reduced solution of y, which was equal to a e raised to power rt. We take its first order derivative, then second order derivative, substitute the values into it, and we can also find out the values of a1 and a2 through the roots which I have solved for you over here. That is r1 plus r2 and r1 multiplied by r2. This lecture finishes over here. After this, we will study the cases of characteristic roots in our next lecture. Thank you very much for now. If there is any question, you can ask.